My best friend from high school. We've been friends for, goodness, what year is this, 2020? We've been friends for 25 years. Yeah, like 25 years. This is the best man at my wedding. Anyway, I'm gonna grab my phone. This first unit that we covered, which was technically Unit 3 in the textbook, covered a whole slew of stuff from randomness to sample surveys to experiments. And I talked about how the polls that people do today are not very accurate. And I still stand by that. I still stand by the fact that polls today, especially in regards to the election, are not very accurate. And I have a bit of anecdotal evidence in regards to that. And again, I want to emphasize the fact that this is anecdotal evidence. Saw something where the guy was talking about, hey, I was doing research and I wondered, how many people have actually gotten phone calls to respond to surveys in regards to like the presidential election. And so he found a bunch of people, and what he found was there was a good number of people that said, oh yeah, I have responded to those surveys on the phone and I've lied. Oh, okay. So not only are they only getting a 2% response rate, but the people answering the surveys are not being truthful. Well, that's just great. So again, for the past, 10, 15 years since smartphones have become a really big thing. When smartphones were invented? Close, 2007. Smartphones were, the first iPhone came out in 2007. Weird prototypes beforehand, BlackBerry, blah, 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 2007. So since 2007, all people have had caller ID. All people know what phone number it is. They can program on whatever they want. And when they get a phone call that they don't recognize, people have evolved into these weird species where they're like, yeah, I don't know who you are, so I'm not going to pick it up. And now all of a sudden, all of the surveys that we've taken for the past 13 years have to be called into question because we're not really getting accurate responses. So my wife is challenging me, and she's just like, well, what are you going to do about it? I'm like, I'm not going to do anything about it. And she's like, no, how do you fix it? I'm like, I don't know how to fix it. I came up with a few different ideas. And then I mentioned last week, I think I showed this to you guys, the one survey about the environment. Right? Okay, he's nodding yes, no one else is. Okay, cool. I showed you the thing about the environment. And I'm like, this is great. She got a thing about the environment, this is a survey, like they're actually reaching out in different ways. And then she got another text message with more surveys. And she tells me, since I responded saying that I would take the survey, they have asked me to take 2 or 3 more surveys. And I'm like, okay. So not only are they getting a 2% response rate, not only are people lying when they actually do respond to the phone survey, but now when they find someone who was actually responding to the text message survey, they keep going back to the same person. This is going to be a fun election. I have done a lot of research. I'm going to be making some introductory videos in regards to my theories in terms of how the numbers are actually going to play out. But we'll get there. But I wanted to show you this, because this was a different survey. I showed you the environmental one from last Wednesday. Here's one from Monday night. So she got this one. I'm not going to go through all of them, like read them all, but I just kind of wanted to show you again, like she got another one. This one was more in regards to the election. Very basic kind of like questions, just trying to get people's opinions. I thought it was really interesting, just the fact that like, as she tried to make it a little bit bigger because she was screenshotting it for me because she knew you guys were going to see it, And I just thought, I just thought it was really cool because like they're actually making an effort to go beyond just phone calls. You can't just go out and find people on the street. You can't, because if you're going to get a random survey of people in America, you would have to have a huge team of people going from city to city to city to city. And you wouldn't even be able to have to go city to city, because if you just survey cities, you're not going to get an accurate reflection of people in America. You have to phone call them, unfortunately, So they just kind of did all that. And then, that was a screenshot I sent her. Oh, yeah. Did you see that from the other day? That was a screenshot I found on Twitter. Fun stuff, huh? Anyway. Good times. But yeah, they're actually trying. They're trying to get more accurate surveys. But unfortunately, it's not working, you know? Some people think, well, in order to get an accurate survey, you got to go like, 50% Republican, 50% Democrat. Okay, what about the independents? You don't know, if you don't know what the accurate percentage of people in America are, Republican, Democrat, Independent, or unaffiliated or whatever, then you're not going to get an accurate poll. Not only that, what percentage of those people are actually going to go out and vote? I don't know. Anybody 18? Okay, did you vote? Don't go vote. I sorry to put you on the spot though. You definitely should all vote when you're 18. I don't care what your politics are. Just go vote. I don't care. Do you know what the percent, hold on, I got to think of the actual thing. It's like turnout rate. That's what they call it. Turnout rate. The turnout rate is basically, okay, here's all the people that are eligible to vote. What percentage of them voted in the 2016 election? What would you think? How would you respond to that? You said 30, you said what? 45? Yeah, it was actually closer to 60. Believe it or not. It's actually closer to 60%. Yeah. But it's never really been like 80%, 90%. It's always been like 55%, 45%, 60%. Yeah. Anyway, let's talk about Derek. In the past couple chapters that we've been covering graphical displays. And I'm going to be continuing that today a little bit more. Hopefully at this point, you would have read the chapters on graphical displays. And obviously the minor that you're taking on quizzes is going to be on graphical displays as well. Some of you have already taken that, but again. I want to talk about Derek though. Derek is an interesting fellow. Derek, when he graduated high school, we both graduated from Southern. When he graduated, he didn't really have that much in terms of prospects. He has worked a number of different jobs. He's worked as a toll booth worker on the Parkway, Fantasy Island, Tom's River Music, Staples. He went up to upstate New York to go visit a friend and then didn't have enough money to get back. So he stayed with the friend and started working at a dollar store up there. Very weird life this guy has had. And he's basically kind of been like nomadic for a while and then stayed in one place for a while. It's very weird. The last big place he lived in was in Seaside Heights up till about 2012 when Sandy hit. And then he had to evacuate Seaside and then his apartment got washed away. His apartment was so stinking tiny. Like, think of this room. And now take this room and quarter it. 1/4 of this room was the size of his apartment. Man, what a life this kid has had. But then about like 5 or 6 years ago, when he was like bumming around, he got a freelance job with a technology website called Tom's Hardware. And he got the job of like reviewing technological parts and things of that nature. It was pretty cool. He used his know-how and he impressed them. And then eventually they hired him full time. And then all of a sudden he's being shipped to all these technological conventions across the country. And he's going to like Florida and Texas and California to stay in hotels on the company dime and review technology. He's going to London, he's going to Hong Kong, and he's making a name for himself. And then he uses all of that experience and all of that name recognition that he's getting in the technological environment, and he turns it into a job with AMD. Anybody know what AMD is? Now, you know what Intel is, right? Okay, you've heard of Intel. AMD is the top competitor to Intel. AMD is an international conglomerate technological company, and he is one of the managers of the PR department in Austin, Texas at AMD. The guy who got stuck in upstate New York because he didn't have enough money to get home is now earning 6 figures with stock options living in Austin, Texas. He's a really cool guy. I'm very proud of him. Look at me. I am 5'6 3/4. Let's round that up to 5'7. Shut up. I'm vertically challenged. Derek is 6'8". This guy, for as long as I've known him, I've just been like this to him. It's super funny. At my wedding, I had to stand on the top step, and he had to basically stand on the floor, and he was still somewhat taller than me. Now, my point being, though, in our group of friends, we had a bunch of people that were like roughly my height. I'm 5'7". I think I was 5'8". I think I was 5'9", somewhere in that range. A couple of people in that range. And then here comes Derek, 6'8". Would you consider Derek an outlier? I'm sorry, let me rephrase. Within our group of friends. Yeah. And then I would ask the question, why? Why would you consider him an outlier? And then your response would be, well, look at him. Sorry, that's not going to be good enough. See, in statistics, you do have to have some justification behind calling something an outlier. And if you've read about it, there are certain formulas that you use to determine whether or not a data point is or is not an outlier. That's what we're going to be talking about today. We're going to be diving back into graphical displays. I'm going to be reviewing some things on the calculator with you. And then we're going to be getting into people dying on the Titanic. Why? For fun. I don't know. So if you have not already taken them out, I'm going to need those notebooks out and open. Oh, people dying on the Titanic. Okay. There we go. And here we go. Here's a picture of Derek. Just so you know. Like, he is so that, like, literally, he would probably, like, hit his head coming in this door of my classroom, you know. My first car that I ever owned was a, what is this? I got a comment? Oh, that's gross. Whatever. Somebody commented on one of my videos, but it was spam. Whatever. Anyway, the first car I ever owned was a 1992 Geo Prism. This thing was so small that I hit my head getting out of it. So you can imagine Derek with his knees up to his chest, just trying to fit in this tin can. Anyway, at least he could always get the cookies off the top shelf. I'm calling this graphical displays continued because we're going to wrap this up, see where it's going. Actually, no, we're probably not going to wrap it up today, but we'll see how it plays out. So here's my group of friends. Now, mind you, I'm going to measure us in inches only because it's better that you don't have two different units. I don't want to do feet and inches. I'm just going to stick to inches. So here I am. There's me at 67 inches tall. Technically 66 3/4, but who's counting? Not me. Anyway. And then here's the rest of our friends. Another friend who's 5'7", another friend who's 5'8", another friend who's 5'9", a couple friends who are 5'10". And then there's Derek. Derek is 80 inches tall. And then the question, and again, it's like, well, clearly look at him. He's an outlier. I know. He is. Just one of those things. When I got my driver's license, I asked my dad, I'm like, hey, Dad, how tall am I? Because I got to fill it in on this piece of paper. And he says, just put 5'8". I'm like, Dad, I'm not 5'8". And he said, don't worry, you'll grow into it. Be sad. Anyway, I'm going to my calculator. Now, these are a little group of friends right here. And Derek, look, he's so tall he can't even fit on the screen. But in order to enter the data, I'm going to hit Stat, and I'm going to hit Edit. This is reviewing, just reviewing with you exactly how to enter in this information. And I'm going to enter in this information like so. There's the group of friends right there. Now you can see there's 7 of us, 67, 67, 68, 69, 70, and then Derek being 80. And now I need to find some information. I want to find some cumulative information. I'm going to hit Stat. I'm going to go over to Calc. And I'm going to do a 1var stat. Now, on your calculators, I believe it does this thing where it goes to a screen where it's like list and then all this other stuff, and then you have to like calculate. Again, you just go to calculate. Mine would just boom, hit enter, and then I get this information. The information that I'm going to write down for now, I'm going to write down X bar is equal to 70.14, and I'm going to write S is equal to 4.53. Zoom out, there we go. These are two very important pieces of information right off the bat. These two pieces of information, X bar being the average. I mean, you know how to take an average. The average is just add them all up, divide by however many there are. But then the second piece of data is your standard deviation. Now, I wrote down, where is it? Marker. I'll find it. I wrote down last time the formula for the standard deviation. But just to give you another idea for the standard deviation, everybody deviates from the mean. Everybody deviates in some direction from the mean. I deviate clearly under the mean. Derek clearly deviates over the mean. But if you were to take an average deviation, that average deviation, again, it's very similar to that number that we have right here, 4.53, because they would be the deviation from the mean. They would square it. They would add them all up. Now, when you take an average, it's like you add them all up and divide by however many there are. But in this case, they're going to divide by n minus 1. And then they square root it back in order to get the data points back to a more manageable unit. 4.53 inches is the standard deviation, is the measure of spread. We wrote that down last time. It is a measure of spread. It's an indicator as to how spread out your data actually is. What do you notice about the average that we have here? What do you notice about the average compared to all my friends? What do you notice? What do you notice? There's something that I notice. I just want to know what you notice. Done? Oh, yeah. Heck yeah. Well, that's one thing right there. Now, in terms of adding or subtracting the standard deviation, that's something that we're going to cover in chapter 5 more so. Absolutely. That has to do with the normal distribution, but we'll get there. I was going to say something a bit more simple. I mean, you're absolutely correct, though. But I was going to say something a bit more simple. Oh, for those of you in the chat, he just basically said that if you took the average plus or minus the standard deviation, it includes everybody but Derek. Absolutely, yes. The other thing that I was going to say was the average is larger than everybody in the group of friends, except for Derek. Derek is the one that caused that average to grow so large. Stupid tall kid. When he was in middle school, he had such a growth spurt that his kneecap split in half over the course of time. I know. So he has 4 kneecaps. Oh, heck yeah. He's had knee problems for years. Yeah. Oh, Derek. Anyway, scrolling back into my calculator. There is more information down below that I need. If you scroll down, you get what is known as the 5-number summary. And I'm going to write those numbers down right here. That 5-number summary is very important. That 5-number summary is how they construct a box and whisker plot, which I'm going to show you on the calculator in a little bit. But we have a minimum. There's me. We have Q1, which happens to be the same number. That does not always happen. That doesn't always happen, but just keep in mind that it did this time. Our median, which is the middle data point, the 50th percentile, so to speak. Somebody asked me, Mr. Markey, where's Q2? And I said, Q2 is technically up there. Q2 is the median. Yeah. If Q1 is 1/4 of the way, Q2 would be 2/4 of the way, or halfway. Anyway. And then there's Q3, the 75th percentile at 70, and the maximum of Derek. Anyone ever watch The Good Place? You have? Yeah. Do you get the reference when I say maximum Derek? No. Okay, never mind. It's in reference to the character of Derek, but anyway. Yeah, maximum Derek. Anyway, if you haven't watched The Good Place, then you're dead to me. I just want to be very clear about where we all stand with each other. Some people are literally shaking their heads. Wow, okay. Let's see. Now the question then remains, is Derek an outlier? Now I contend that he is, you contend that he is, but we have to prove it. To show a data point is an outlier, it has to be outside the following range. Dot, dot, dot. To show a data point is an outlier, it has to be outside the following range. And that range is this: Q1 minus 1.5 times IQR, which we talked about IQR last time, but I'll refresh you of that in a little bit. Q3 plus 1.5 times IQR. Okay. Now we have all that information, except we just have to remind you as to what IQR actually is. First of all, what do the letters IQR stand for? Remind me. Interquartile range. Yeah. Range is a dumb calculation, but interquartile range is much more important. Interquartile range. Y'all remember how to calculate interquartile range? Off the top of your heads? Yeah, it's just subtracting them. Instead of taking the max minus the min, you would just do Q3 minus Q1. Again, IQR is another measure of spread. I'm saying that because of the word cus that I introduced to you last week. Center, unusual features, shape, and spread. A measure of spread tells you how spread out the data is. In this case, Q3 minus Q1 would be 70 minus 67, which is clearly 3. And then I'm going to go about doing this calculation. 67 minus 1.5 times 3, comma 70 plus 1.5 times 3. This should give me 62.5 and 74.5. Now, a couple things to this. If you are shorter than 5'2.5", then you would be considered an outlier for our group of friends. If you are taller than, what is that, 6'2.5"? 6'2.5", you are considered an outlier for our group of friends. By this definition, we can declare Derek an outlier. Can't just say, well, just look at him. He would be mad. Because Derek is outside this range, he is considered an outlier. By definition, that is exactly what we would say. Because I did this calculation, because I showed that Derek was outside of this range, he is definitely an outlier. Let's take a look at some graphical displays on the calculator. I'm going to zoom in on this. Again, just reminding you as to how to do these graphical displays. It'll focus in a moment. There it is. On the graphing calculator, again, mine's slightly different than yours because I have the 83, no worries. If I hit second y equals, it brings me here. Second y equals brings me to all of my plots. All the plots are turned off. Again, this is just reminding you as to what I showed you last week. We hit enter in order to turn one on. There it is. The only ones that we are concerned with are, for now, are either going to be the histogram or the box and whisker plot, more specifically the second box and whisker plot. Oh no, I can't see anything. I graphed it, but nothing happened. Oh, I have to resize my window. Zoom what? Zoom 9. Zoom 9 will do it better. Zoom Fit actually tries to do it for if you have an equation in y equals, but that doesn't really work most of the time. I, in fact, hate Zoom Fit. I do Zoom Stats much better. Haha, there it is. Holy crap, look at that. would you call that shape? What would you call that shape? What I just drew? Definitely skewed right. Definitely skewed to the right. You look at the skewedness in terms of where the tail is, and the tail, of course, is to the right. But then the other way of thinking about it, because someone might argue, but Mr. Markey, clearly look, it's all to the left. I understand that. Most of the data points are to the left. But when you're talking skewed right, you're talking about the idea that there are data points or a data point that is pulling all of the information in one direction. What direction is it pulling it in? It's pulling it to the right. And because of that, this is definitely skewed to the right. Because this is skewed to the right, I go back to cuss. What center would I use to describe this data? It's either going to be X bar, the mean, or the median. Which one do I use for this set of data? Remember? The median. If it's skewed, you use the median because the average has been heavily tampered with. The average is tampered with when you have something skewed like this. So you're definitely going to use the median to describe this. What about in terms of spread? In terms of spread, we either have IQR or standard deviation. What are we going to use for this? IQR, interquartile range, or standard deviation are both measures of spread, but which one are we going to use for this data? You get a 50-50 shot if you want to guess. No one wants to be wrong. Go for it. IQR. It is IQR. Standard deviation is a measure of spread. And when you take the standard deviation with Derek in it, believe it or not, that standard deviation has been stretched out. It has been stretched out because of Derek. Now I'm going to do something in a little bit. As a statistician, it is important for you to know that if you have an outlier, you are to run an analysis both with the outlier and without the outlier, if you have defined an outlier, which we have in Derek. So I'm going to recap the analysis that we just did with Derek, but then I'm going to remove Derek and rerun the analysis. I will do that in a little bit. Let me show you the box and whisker plot real quick before I do that. And again, box and whisker plot, I'm just going to go back to stat plot, boom, change it to the second one, or the second box and whisker plot, zoom 9 it again, boom, there's the box and whisker plot. As a side note, I'll hit trace real quick. There's the median. I want to go over the minimum. There's the minimum. The minimum is at 67. And Q1 is at 67. That does not always happen. That just so happened in this particular instance. I just wanted to make sure you're aware of that. This is the median. This is Q3. What percent of the data did I just shade in? 25%. I just shaded in 25% of the data because the median is the 50th percentile and Q3 is 3/4 of the way up in the data, the 75th percentile. Between them is 25%. In fact, between all of these is 25%. I mean, technically there's supposed to be a gap between them, let's say, Well, so it's supposed to be 25% there, 25% there, 25% there, and 25% there. But again, this is just weird because they share the same space. But I'm going to remove Derek. Let's remove Derek. He may not like it. Somebody asked me, does Derek know that you talk about him? Yeah, I always talk about Derek. What better outlier could you ever have than Derek? If you're familiar with my personal YouTube page, then you may be familiar with The Derek Show. Nobody? Weirdos. Oh, you will. Anyway, if you have an outlier, a good practice is to analyze with and without outlier. If you have an outlier, it is a good practice to analyze both with and without the outlier. So here's with Derek. With Derek, our X bar was 70.14, our mean, that is, and our standard deviation, how spread out the data is, was 4.53. Our median was 69, the middle data point, and the IQR was 3. And we looked at the histogram, and it was heavily skewed to the right. That was with Derek. That's just a nice little summary just of numerical values, and we're able to look at the graphical display and things of that nature. But now we have to look at it without Derek. So I'm going to go back into my calculator. I'm going to have to remove Derek from that list. Just as a reminder, I'm just going to zoom in a little bit and zoom, so you can see exactly what's going on here. In order to remove Derek, you can't hit clear. You actually have to hit the delete button. Just so you know, you actually have to hit the delete button. But I'm going to rerun that analysis. Stat, calc, 1var stat. Oh, interesting. Lots of information up here. Now, I have it written down, so I'll just kind of show it to you and then write it down a little bit. But a lot of things happened. There's the other pieces of information that you may need. I removed Derek. Let's take a look at the graphs real quick. I have all that information written down. I'll write it down for you in a minute, but let's take a look at the graphs real quick. Here's now the histogram. Oh, wow. That's strange. I mean, yeah, there's a little bit of a gap here, but look at this. What would you call that? I would call it symmetrical. Yeah, it's got a little gap there. It's not perfect. It's not perfect, but it's pretty darn symmetrical. Oh my gosh. Let's look at the box and whisker plot. Let's look at the box and whisker plot. Enter box and whisker plot, zoom 9 it. Oh crap. Look at that. Did it look like a monster face looking at you? Hold on. Just saying, I don't know. One of the funniest things that I've ever had the commentary on in my life is the fact that when you do something that's kind of funny, but not super funny, people kind of give you the courtesy of just breathing quickly out their nose. There you go. See? There you go. Anyway, zooming out. Let's write down some of this information. X bar, according to that, was 68.5. The average went back down to a much more manageable number once we removed Derek. The standard deviation, oh my gosh, that thing shrunk. It shrunk because by removing Derek, the average deviation of everyone else from 68.5 is incredibly small. The median did change, but it changed by a very, very insignificant amount. In fact, think of it this way. Do you remember how many data points we had with Derek? We had 7 data points. And you guys remember how you did median back in the day where you listed them and you went boom, 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 all the way to the middle. With 7 data points, you get a middle data point. But when you remove Derek, you only have 6 data points. So you get to the middle and there's 2 numbers. What do? You average them. That's how they got the median here. So the median didn't really change by all that much. The IQR remained exactly the same. The IQR remained exactly the same. I mean, that doesn't always happen, but it did in this case. And the data was symmetric. Now, here's the thing. Heavily skewed implies that median and IQR are what we need to describe the data. Symmetric implies that mean and standard deviation are what we need to describe the data. There are better indicators to show how the data looks. When you see a standard deviation like 1.38 compared to a standard deviation of 4.53, you can say that the 4.53 data is much more spread out. And you can say that the data with the smaller standard deviation is much more consistent. It's much more consistent with a smaller standard deviation. In fact, you'll find that on various problems that we eventually do in like chapter 5 and beyond, where you have like a factory and they're producing some kind of object using their machines, and they want consistency between each object that's coming out. And the idea is that, well, in order to get the consistency that you want, it's not going to be perfect, but you want to have as small a standard deviation as possible. That's what you really want. And there are ways that you can kind of force that. But it depends on the situation that's in front of you. Waha! Waha! I literally just raided the copy room for paper. I mean, come on, nobody's using paper anymore. You always plant more trees. Anyway. Whee! Something that you may have read about, but something I really want to get into the details of. Categorical. I guess that's how you spell it. Whatever. When we're talking about Derek and the heights of all my friends, we're dealing with quantitative data. Quantitative data. With quantitative data, it makes sense to average the data. It makes sense. I could say, well, the average height of my friends is blah, 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 or whatever it is. That makes sense. Cool. The key word in quantitative is quantity. If I can spell it. Quantity. That's a U. Quantity. I'm a math teacher. I don't have to know how to spell. Quantity. That's a terrible way I wrote that. Anyway. Quantity is an amount, of course, and you can create something like a box and whisker plot. You can create a histogram. You can create, I think you did these back in middle school, stem and leaf plots. I don't know when you would have made them. Did you make those? Cool. Do you know what grade it was? All right. But yeah, stem and leaf plots. You can do that with quantitative data. You can make a dot plot. Dot plots are dumb, but you'll see them every now and then. They're literally just like histograms, except they use dots. So dumb. But that's quantitative data. It makes sense to average it. It's a quantity, things of that nature. Shoe size, height, age. I don't know. How much money you have. Somebody give me your favorite color. Okay, green. I need more. Blue. Okay, couple more. Orange. So green, blue, orange. Yellow. Okay, is it really your favorite color? You just didn't want to say the same one. I don't know. I don't care. Question. What's your average favorite color of the class? What's the average favorite color of the class? Well, you get brown divided by brown is 1. Here's the thing. It doesn't make any sense for me to say what's your favorite average color. Okay, what city do you want to go to and visit and vacation in? Who? Sure, Honolulu. Name another. Sure. What's the average of Honolulu and Miami? It doesn't make any sense because those two questions that I asked you are questions getting categorical data. It doesn't make sense to average. Say again? It depends. I think you're either overestimating or underestimating where Hawaii is. Yeah. You know, they got rid of it, but many years ago on Google Maps, you could Google America or United States to Japan, and it would actually give you directions. And at one point, you'd get to California, and they would say, "Now get in a paddle boat." And anyway, they got rid of it though. Oh no, they didn't get rid of Hawaii. No, my bad. No. Anyway, it's either a category or a quality. Quality. Now they say quality because categorical data also goes by another name. They also call it qualitative instead of quantitative. But I just want you to know they have a certain quality. Typically given as a count or percent. It's typically given as a count or a percent. Now, if I asked everybody what's your favorite color, I can make a tally on the board and I can have a count for all of that. And then I can say there's like 7 of you in here, and I can say, oh, this percentage of the class said, this color was their favorite. And I can give it to you as a percentage, or I can just give it to you as a count. Out of 7 of you, 3 of you said this color. Cool. With that, you can make a bar chart. Bar charts are not the same as histograms. Bar charts are used for categorical data. You can also use the world famous pie chart. A pie chart, which is nice. Now, I want to talk about the Titanic because I'm sticking with categorical data. Now, yesterday I made a bit of a mistake in describing my data. Now, the numbers that I gave were absolutely perfect, but yesterday I started by saying that the chart that I'm giving you was deaths on the Titanic when it really should have been people on the Titanic. I was killing people before they were dead. So, anyone ever see Titanic? Whatever. Fun fact, back in the 90s when this thing was released for home theaters or whatever, right? We didn't have it. My family didn't have a DVD player, so we had to get the VHS. But the movie was so stinking long that they sold it to you in 2 VHSs. VHSs were these plastic devices that they used to have. All right, shut up. Oh, goodness gracious. Do you guys remember Laserdisc? Yeah? Okay, imagine DVDs. Now, imagine they were dumb and they were like this big, like the size of a pizza. I'm not even kidding you. People had laser discs, and they would take these things like a record and put it in the machine. It would take 10 minutes to load, and then you could watch the movie. It's the dumbest thing in the world. Anyway, let's call this people on Titanic by class. Eventually, we're going to talk about people dying. We'll get there. And satisfy your bloodthirst for people dying. Anyway, I'm going to give you the category, which in this case is the class that they were in. I'm going to give you the count, the number of people in that particular category. And I've already done the math for you. I'm also going to give you the percent of the breakdown of people by class. So on the Titanic, you either had a first-class ticket, a second-class ticket, a third-class ticket, or you were designated part of the crew. Now, in first class, they had 325 people. There were 285 in second class. There were 706 in third class. And there were 885 people in the crew. I've already done the math for you. 14.8%, 12.9%, 32.1%, and 40.2%. Move that over a little bit. There we go. Give you a moment to write that down, of course. But again, this is categorical data. I'm not only giving it to you as a count. You can give like a tally mark on the board or something like that. Or I'm giving it to you as a percent. Now, it doesn't make much sense to say what's the average class of people on the boat, just like it wouldn't make much sense. Okay, in this school, we have 9th graders, 10th graders, 11th graders, and 12th graders. What's the average grade level? That doesn't make any sense either, because that's categorical data. And if you have categorical data, you cannot present it in the same way that we did people like Derek and his height. I don't know. Unless you broke it down into like short people and tall people. Whatever. You know the movie Toy Story? You know the guy who wrote the song for Toy Story, Randy Newman? The You've Got a Friend in Me guy? Cool. Look it up. He wrote a song in the 1980s that was banned in the state of Maryland. It's called Short People Ain't Got No Reason to Live. Have you heard it? It's pretty funny. Anyway. Why did they let me do this job? Anyway. I'm going to underline a couple words. A relative chart is referring to a display with percentages. A relative chart is referring to a display with percentages. I want to be very clear about this. It could be a relative bar chart. It could be a relative area chart. It could be a relative pie chart, although pie charts are typically always relative based on the size of the slice. But whenever you have that phrasing, I just want you to be aware that the word relative is referring to percentages. If I say, out of the blue, hey, there were 325 people in first class on the Titanic. Okay, that doesn't mean much to me. But if I change it and say, oh, 14.8% of the people on the Titanic were in first class. Now, all of a sudden, you have some framework. Oh, 14.8%, something along those lines. A percentage is much easier to be able to frame it because it's all within the confines of 100%. Now, I do want to show you how to make a certain type of chart in a moment. But first, I want to show you something on Google Sheets. It's kind of nice. There we go. I don't know if you knew you could do this, but on Google Sheets, you can create certain types of graphical displays. Class, well, that's really small. Hold on. Oh, it's at 80. That's weird. First, second, third, crew. Count 325, 285, 706, and 885. It bugs me when it's not centered. There we go, much better. There we go. Now, I love, yes. Oh, yeah, just fill this out for me while I do this. Here we go. Now, I love Excel, but if you highlight these two columns, you got a pen? Okay, good. When you highlight these two columns and click Insert Chart, ba-boom! It creates a graphical display for you. And what's really nice about this graphical display is that if you go over the individual pie slice, it also gives you the percentage, which is nice. It automatically calculates those percentages for you. I mean, you could have Excel do that, but you need to work around some of the formulas, which is nice. But now here's the other thing you can do. Check this out. You can also change, oh, I got to sign it real quick. Yeah. You could also change the type of chart that you have. There we go. So now I have this little bar chart here, which is kind of nice. Now, unfortunately, they don't give you the percentage in the bar chart. I mean, you could mess around with some things. I want to change that color to red. There we go. To represent death on the Titanic, which is nice. You can do all sorts of things. I got to center that. That's bugging me again. Hold on. There we go. Much better. You could change this around. You could also do, hold on, setup, type. I don't really like this line chart, but you could do that, a 3D pie chart. That's cool. I like that. And then the individual pie slices. Just kind of nice. You can create these by hand. You could have Google do it for you. It really depends on what type of data you have. Really nice. Let me get rid of that real quick. Let me see, what would it do here? If I just highlighted that one column, still gives me a pie chart, but it doesn't give me those. Will it give me the opportunity to pick other things? What's that? Histogram? Ooh, give me a histogram. You can do stuff like that. That's kind of nice. I don't know if you guys have ever messed around with these. Candlestick chart. Ah, that's gross. I don't know. I haven't really stuck around with some of these other ones. A gauge. Look, a gauge. I have no idea. But it's really nice the way they do these things. Question, honest question. Have you guys ever been taught how to mess around with Excel or Google Sheets in terms of the formulas? Man, that really should be a class. Kinda? Okay, it really should be a class. Oh man, it's so nice. Just in terms of the way the formulas work out. I can't tell you how much stuff, how it's saved me time and time again to do that. But what I really want to show you is I want to show you a special type of chart that you may not have seen before. Maybe you've read about it in the book. I want to show you a segmented bar chart. Ooh, before that, I got to give you a star. Have I ever written a star into the notes before? This year? Have I ever written a star? Okay. Have you ever known someone who has overused exclamation points? All right, you're saying that because you're the one who does it. Okay. Exclamation points should not be overused. They should be saved for very celebratory opportunities, just like stars. Stars should be reserved for the most important of statements, and I may only give you a handful of stars throughout this entire year. If I could draw it, there's a star. They're very important. When you create a graphical display, you must include labels and a title. When you create a graphical display, you must include labels and a title. You must. If you do not, there are points that will be taken. Please be careful with that. Let's talk about a segmented bar chart. Now, a segmented bar chart, you may see time and time again. It's fairly easy to see what the thing is about, but I want to draw it for you, and I want you to draw it in your notes as well, just so we're on the same page with this. This marker's dying. Let's just pretend I made that. See? That was a great shot. Just saying. You guys don't know how to back me up. Anyway. Create a little thing here. I'm going to go up the sides by 25% each time. I'm going to label the left side as percentage. And now I'm going to have to do something cumulatively here. First class was 14.8%, which was roughly this. I'm going to label that after the fact. 14.8 plus 12.9 puts me up at about 27. I'm going to have to go there-ish. I'm just estimating. Plus 32.1 puts me at about 60%. And the remaining would put me there. Now, I still got to label some stuff. This is first class, second class, third class, and the crew. I'll zoom in. There we go. And I'm also going to label by the percentages. I probably put them on the inside if I had room, which I don't. So I'm just going to write them on the side right here. 32.1% and 40.2%. And the only thing that I'm missing is a title. People on, someone get that? Titanic by class. Give it a nice little title there. Now, this is everything that you need. I mean, it's one type of categorical display. It's still a bar chart, but it's a segmented bar chart, meaning all the bars are put on top of each other, and clearly they add up to 100%. Sometimes it's in your best interest to do a segmented bar chart. Sometimes you're going to be asked to analyze a segmented bar chart. But I have all of my labels, appropriate scale, and a title to give the whole thing away. When you draw something like a graphical display, it should be drawn in such a way where if somebody came in from the hallway and looked at this, they would know exactly what you were trying to convey to them. I'm looking at this, I'm like, oh, people on the Titanic by class. All right. Well, it looks roughly like 40.2% of the people were crew and 14.8% were first class. And there's the percentages, and that's all the types of people that were there, because clearly it adds up to 100%. I know everything that this graph is trying to convey, because you have to label it appropriately and title it appropriately. Now let's talk about people dying. You probably need this. Can you pass that back? Yep. Oh, there we go. Let me draw a little table here for you, and you're going to draw this table for me. Let's see here. It's going to be 1, 2, 3, 4. There we go. 203, 118, 178, 212, 122, 167, 528, and 673. I'll zoom in. Whee! This is first class, second class, third class, and the crew. And furthermore, alive, dead. These are people on the Titanic who died, and the people who lived. It was a disaster, to say the least. Now, this is called a couple different things. In some places, they may call it a two-way table. They may call it a two-way table because it's a table, but it's coming from two different directions, where one side is class and one side is like, I don't know, your mortality rate or something. I don't know what to call it. But they also refer to it, and that your textbook, I believe, does use this terminology, but they also call it a contingency table. That's incredibly helpful. It's incredibly helpful. Because with all this information, I can ask various questions with this categorical data being thrown at you. Whether this is a version of a categorical display, technically, even though it doesn't give you any like shapes or bars or anything like that. I could ask you the question, hey, if you were on the Titanic, what is the probability that you're alive? Or I'm sorry, that you survived? I should say, something like that. Well, if I want to do a probability here, I would need two numbers. I would need a fraction. I need a number on top. I need a number on bottom. You might need some more information. Okay. If you add up everybody in the alive row, this adds up to 711. If you add everybody up in the dead row, that totals 1490. Which those two numbers add up to 2201. Okay. Now I'll ask the question again. What is the probability that you were alive / what fraction do I really need to be setting up right now? Yeah. 711 over 2201. Which, if you did the calculation correctly, 32.3%. That is the probability that you were alive, that you survived the Titanic. That actually really sucks, 32%. Hold on, what's going on?
Please excuse the interruption. I'd like to congratulate the September Student of the Month winners, Jayana Bivens, 9th grade, and Sophia Nieto, 10th grade. Can you please report to the main office at this time? And again, congratulations. Thank you.
Haha, 11th and 12th graders, you don't get anyone. I don't know. So I change it up and I ask a different category. What is the probability that you were part of the crew? Well, if you were part of the crew, this totals, as we saw from the previous charts that we made, 885. If that's 885, what fraction do I need to be setting up for the crew? Wait, say that again? 212? Yeah. I want to say what he says. Yeah. I didn't hear what you said. Yeah, I got you. I know why you're saying 212. I know what you're saying. Yeah. You were going to say? Yeah. It should be 885 over 2201 because it's just the question, okay, what is the probability that you were a part of the crew? I didn't put any other caveats on that whatsoever. I didn't put any other caveats on it whatsoever. I just said, what's the probability that you were part of the crew? There were 885 people a part of the crew out of the whole boat. And this is the percentage that we wrote down earlier. There's the 42.2%, or the 40.2%. But now I have a big question for you. A big question. What is the probability that you are alive, given that you were a part of the crew? Now, this is a different type of question. Alive, given. That's what this symbol means, by the way, this vertical line right here. It means the word given. Given that you are part of the crew, given that I'm only looking at the crew, given that I'm limiting my scope to only looking at crew members on that boat, what is the probability that you are alive? Do you get it? No. Yes. Given that you're looking at only the crew, given that you're only limiting your scope to the crew members, means you're only looking at the 885 crew members. Once you limit that scope based on the given statement, then you're looking at 212, which, for the sake of argument, is 24%. It rounds up. 24%. Now, I just want to write down something really quickly. And I want to talk about it after I write it down. I want you to write it down as well. Because I'm running out of time. Look at the difference for that last calculation. Now, I'm going to talk more about this next week because I am out of time. Do not forget the quizzes. We will pick up with more of this next week. I just wanted to show the difference between these two. But anyway, we'll talk more. Everyone go away. I don't know. Click. click,